Hey all, last section of chapter 5. Now remember, we're not going to do all of chapter 6. It's only going to be the first 3 sections. That's still included in our course outline. But yeah, we're almost done. And I know the last video was very short. This one actually might be even shorter. So nice thing is we're rolling in, hopefully with the head of steam, feeling comfortable with these integration processes, all the different looks, going into more of an application base of this integration in chapter 6. Again, just 6, 1, 2, and 3. Enough about that. Let's get to 5, 7, which is all about inverse trig functions. Now, although this is the last section, which oftentimes means it's the most challenging or application-based, whatever it might be, this one fairly simple. Okay, and it's actually not something that we will see much of, other than I want you to make sure that you at least recognize these when you do come across them down the road in Calc 2 or 3. Here we go with some inverse trig functions. Let me give you the definitions, talk to you a little bit about what they might look like differently when we actually see them. And of course, we'll meet in class and go over these to make sure that we understand them even better. All right, well, here's the one and only definition from 5.7, 5.71, which if you look at these, they're pretty nasty as is, which is why the result of these ends up being something not so nice. So I can go through actually why these are what they are, and I'd be happy to do that in class if you'd like. I can even do a little bit of it right now. But the main thing is I want you to know that what we're going to end up with whenever you see fractions and things, notice they are U's and A's, where A can be any number typically, and then U can be any other function like 2x or sine x or whatever it might be, x squared even. When you see things that have radicals or just a bunch of squares in the bottom, notice this one and this one very similar. Okay, obviously the slight difference is you'll have that function on the outside that we're calling U, and the positive versus negative on these is reversed. Now we can always have one that doesn't have it, and it's also addition. Now that plays a little bit different role. Here the order really matters, which one's positive and negative, where this, it can be listed in either order. They could have, for example, an x squared plus 1 or a 1 plus x squared, and you need to know that those are one and the same. Now, I don't mean that a and u are the same, but of course, a being the value and u being the function. So let me give you the list of what these are one at a time. And like I said, if you'd like me to explain this in a little bit more detail, even a little bit here, I can do that. But let's talk about what we end up getting, which is pretty obvious, stated in the title, are inverse trig functions. So the first one here, when we have a square root of a squared, a value, minus some function squared, u, we end up with the inverse sine function, where our u function is on top over the absolute value of a. Again, absolute value because these things are squared under the square root. We got to make sure that we get that. Plus c as well, because hopefully we don't have to evaluate inverse trig functions, if you remember that from back when you took it. All right, the next one, a squared plus u squared in the denominator with our u derivative on top. That would give us inverse tan of u over a. Just like we had here, notice we don't have to specify that the a is positive because it's already implied down here. Right now, this also has the 1 over a on the outside, so whatever that value squared is that you take the square root and get the a for, you'll also have that fraction out in front. And it's just safer to put 1 over a rather than this whole thing over a, because then that starts getting a little ugly and you could make mistakes. All right, the last one, when we have the u function on the outside of our square root of, again, notice the u squared minus a squared rather than the a squared minus u squared, that's going to yield the inverse of secant, which remember is just the reciprocal of cosine. Now again, notice the results of all of these had the u over a. Some of them had the 1 over a. In this case, we got to make sure that the a is positive for this one. But that's it. Anytime you recognize roots and or squared, whether it's the sum or the difference, you should be thinking inverse trig, sine, tangent, and secant. May run into these down the road, not too much in this class. So again, wanted to show them to you so that you at least say, oh yeah, I remember those, and then go look them up. That's it, my friends. Short and sweet, just like my wife. Y'all take care. I'll see you at the next one.